All right. Okay, so it says if sine theta equals -3/7 and theta is in the fourth quadrant, find the cosine of theta. So the first thing that I usually show students when they're working on problems like this, there are 4 reference triangles. There's this reference triangle in the first quadrant, there's this reference triangle in the second, and so on in the third and the fourth. And it kind of looks like a bow tie to me.
Yeah.
But what I would do is get this like really well down in your brain so that whenever you know which quadrant it is, you just immediately draw that triangle. And then more importantly, you draw the correct angle that goes with it. So the angle is there. The sine of that angle, opposite over hypotenuse, 3/7. Where does the negative go? It goes with the side, okay? The hypotenuse is always positive. And then from here, you're using Pythagorean theorem, a squared plus b squared equals c squared, to determine the missing side. So for you, let's just call this a squared plus -3 squared equals 7 squared. How comfortable are you solving, reducing something like this?
I'm pretty comfortable with that.
Fantastic. So from here, we're just solving for a. We're subtracting 9 from both sides. A squared equals 40. We're taking a square root of both sides. So a equals, and then to reduce a root like this, you're using prime factors, building a factor tree. There's a few other methods, but this one reduces to 2 square root of 10, and that's your side. It's not the answer, but that we need that to move forward.
Okay.
So if you're gonna send me more problems like this one, they're gonna be very similar in the recipe. You figure out which quadrant you're in, you draw the triangle, you label the given sides, you find the unknown side, and then you can finally figure out what cosine of theta is. Cosine of theta is adjacent over hypotenuse. And so in terms of how you answer that, you're probably already familiar with that. You've got to write it out as 2 square root 10/7 or /7, something like that.
Okay.
So give me some feedback. Was this clear? Is this the kind of explanation you were looking for?
Yeah.
Excellent.
So should I share my screen again?
So yeah, you can either enter the answers as we go, wait till the end. This is totally for you. So if you want to share your screen, if you want to snip questions and drop them into the chat, whatever you want to do. My goal here is to help you as much as I can during this time we've got.
I'll go ahead and enter the problem. I mean the answer.
Great. And is this grade you immediately on the?
Oh yeah, it tells you if it's right or wrong.
Excellent. Let's do that then, so you get some feedback in case something gets entered wrong.
Right.
Or we work it out incorrectly. Okay, is there potentially another problem like this? Could you maybe just, or is it just you only can do it as you go? No, it's not helpful. Yeah, keep going. No. Okay. Nope. All right, we only get one of those. Okay, let's go back to the question 5. I'll grab a snip and we'll repeat here.
Okay.
All right, so I just have to remember to share my screen. If you ever feel like I'm not sharing and I should be, let me know that.
Okay.
Okay, without using a calculator, compute the sine and cosine of 150 degrees by using the reference angle. So in truth, like whenever I see something that says, like, don't use a calculator, like by using a calculator, that's where you're gonna, it's kind of like, that's the shortcut to doing this. Are you generally allowed to use a calculator in this class, or is it?
For right now, yeah. But she said, the further we get into the course, we won't be able to use one sometime.
Got it. So what I'm going to do right now is I'm going to drop into the chat a trigonometry reference sheet. This is all the formulas you're going to need for this class. And it's pretty overwhelming at first, and you may have already seen one of these, but it's really important to be able to have a lot of this information down. And we're going to look at the unit circle together next. So at some point, you're going to want to like memorize the unit circle, everything in the unit circle. Sometimes instructors even give you a test. Are you in person or is this an online class?
We're in person.
You're in person. Okay. So they like to give you a blank unit circle and say, fill this out, and go.
Yeah.
And you can get there. You can get there. But in terms of like, what does this mean? So 150 degrees on the unit circle, it's counterclockwise. Now, I don't know why that is. Whoever came up with this, it's counterclockwise. That's a full 180. So we're not quite going that far. We're going 150. And so the reference angle, by definition, is the angle made with the x-axis.
Okay.
Okay, so it's like, well, how much further do you need to get to the x-axis? Well, that's why you wrote 30. Okay, because it's literally 30 more degrees to get there.
Yeah.
Okay, and it's in quadrant 2. Perfect. Okay, so here's why. Here's the power of this reference angle. You can convert the sine of 150 degrees into either plus or minus the sine of the reference angle, which in this case happens to be 30 degrees. Okay, now you're probably saying, well, how do I figure out whether it's plus or minus? That depends on what quadrant you're in. That's what this is referring to. So have you seen this in class, ASTC?
No.
Okay, so it stands for all students take calculus. Whether that's true or not, it is the words you say, or that's what they generally tell you. Now, here's how you use it. If you look at the first quadrant here, all of the output values are positive. They're all positive in the first quadrant. Okay, but sine in the second quadrant is the only one that's positive. So sine is positive, cosine is negative. All right. So we now know, okay, it's positive sine 30. So it's a recipe. You figure out what is the reference angle, which quadrant is, because that tells you whether it's plus or minus. Then you got to go to the unit circle, and there's 30 degrees. And do you remember from class whether sine is the x or the y value?
Isn't it I feel like it's into the y value?
Y is the sine value and x is the cosine value.
Okay.
And that's just something you got to remember and get down and be really, really good with. So all of that being said, the sine of 30 degrees is the y value right here. It's 1/2.
Okay.
Okay. Now just let that like sink in for a moment. There's like 4 things you got to do to figure this out. And yes, if you go to that page 3 of the unit circle that I sent you in the chat link, you could just read off the answer. But that's why I asked you, like, are you going to need to know this stuff without looking at a reference sheet? And it sounds like you are. So for cosine 150, it's plus or minus cosine of 30 because 30 is the reference angle.
Okay.
Okay. And then now we have to decide, was it positive or negative? Well, in the second quadrant, which is where we're at, where 150 degrees is at, not the reference angle, the original angle, where the original angle is, cosine is negative in the second quadrant. Now, again, that's because sine is positive, S is positive, so everything else is negative. That means cosine is negative. So the cosine of 30 degrees is the x value. The x value there at pi over 6 or 30 degrees. So it's negative square root of 3 over 2.
Okay.
So whenever you're ready, yeah, great. You're sharing your screen already. You can watch you answer those. Now, is the goal to get through 7.3 homework, or do you have more to do than this today?
I do have more. I can go there real quick.
Well, yeah, just want to make sure we're going at a good enough speed. I mean, we'll probably have plenty of time. Just to make sure we get done everything you want to get done today.
If I do this one, it'll probably go over mostly everything that that was in that last one. If that makes sense.
Sure.
So this one might be a better
okay
thing to do.
Do you have a test coming up here
Um, yeah, I have a test on Tuesday.
on Tuesday? Cool.
Hmm.
Well, that's great that you're getting some help before the test.
Yeah.
All right, so let's look at this problem together, and I will share my screen, and we will look at that. Okay, it says this is a triangle. Like I know that it's a triangle, and suppose A is 2. So I like to immediately write that in.
Mhm.
A is 45. Great. That means the other angle is 45. And so this is a special triangle. And like you heard that in class, but what does it really mean? It means that there are known formulas for finding the legs and the hypotenuse. And in other words, you only need one side to find all the other. So am I given, is 2 a leg or is it a hypotenuse in this problem?
It's the leg.
It's the leg. So the legs are the same. So B is also 2. That's what this reference triangle means. It means whatever the one leg is, so is the other. The hypotenuse over here, C, I actually think this is better said in words. It's the leg times multiplied by the square root of 2. So you take whatever your value of your leg is, which is 2 in this case, and you multiply it by the square root of 2.
Okay.
Have you seen that before in class?
No, it's my first time.
You've never, so this is new. This is something
I mean, I seen the problem, but the leg times the square root of 2, I've never seen that before.
okay. And it's good for me to know here. I'm trying to, so there's another style of problem where they give you the hypotenuse and you have to go the other way.
Hmm.
Have you seen this special triangle before? The 45,
Um,
45, 90?
oh, no, no, no.
Interesting. Okay. All right. Okay, well, let's go ahead and look at another problem. There's another special triangle. We'll see if it comes up in our lesson for today.
Okay. Think about my online assignments. A lot of the stuff we haven't even gone over in class. So
That's got to be pretty frustrating.
yeah, so like the little circle thing, I've never seen that before.
Okay, and you will like that. Like I'm not. This isn't like one of those things where you are going to get to it, and
Yeah.
maybe you'll. So anyway, let me grab a snip of this, and we'll take a look here. All right. Yes. All right, so I am sharing my screen again.
Okay.
So this time, I guess I will redraw the triangle here. So the hypotenuse is 13 and
Mhm.
angle A is 70. So all of that stuff that I just mentioned about X and X root 2, it does not apply to this problem. This is just a boring right triangle.
Okay.
Okay, so when you have a right triangle, which the other one was, you have A squared plus B squared equals C squared at your disposal. And you
Mhm.
also have sine, cosine, and tangent. Okay, and I referenced those in the previous problems, but I'm hoping that you know these relationships. When I'm writing this,
Yeah.
you're clear with that. Okay.
Uh-huh.
So the problem essentially is telling you to solve the triangle, and you might even see that on a test. Like that's the language they like to do. And what that
Uh-huh.
means is to find all sides, all missing sides, and all angles. Well, let's find that other angle because that's the easy one to do. This one is 20 degrees because they add up to 90. Boom, got that one. Okay. Now your choice here. Do you want us to find side A or side B next?
Um, let's do A.
Let's do A. Now, what word would you use to describe A relative to 70 degrees? Is it the opposite, adjacent, or the hypotenuse?
Opposite.
Opposite. So the sine of 70 degrees equals opposite A over the hypotenuse 13. Have you been doing that in class?
Yeah, we've been doing this.
Good, good. So to solve for A, you're going to multiply both sides by 13. So A equals 13 times sine of 70 degrees. Now, what kind of calculator do you have?
I just have like a regular
Like a TI 83,
No.
84? What do you got?
Casio FX.
Oh no. Oh no. No. Okay.
That bad?
Um, well, most often the TIs are the most commonly used. They're not, it's not that they're better or anything. They're just well marketed. Um, I will remind you that your mode has to be in degrees when you do this
Yeah,
calculation.
it is.
Okay. So
She
I'd like you
reminds
to,
me of that a
I'd,
lot.
okay. I'd like you to calculate that for me. And then I will also do the same, but I want to make sure this is an important thing for you to be able to do in the class here. So 12.216.
Yeah.
Is that what you got?
Mhm.
Perfect. Okay. Now what's kind of nice is at this point, you actually have a choice. You can either go back to Pythagorean theorem because you have now two of the three sides, or you can keep using your trigonometry, your
Mhm.
sines and your cosines. So which do you think you would do at this point to find B?
We do. Um, See, this is where I get confused because how do you know which side to use if you're trying to find B? Like, does
Okay,
it
so
matter?
let's keep going with that. So now and actually I'll do it in a different color because that'll help here. So relative to angle 70, okay, B is now the adjacent.
Hmm.
Okay, so that tells you you're going to use cosine because cosine uses the adjacent and the hypotenuse.
Okay.
And you could sit here and say, well, hey, Matthew, like, can I use tangent because that's the opposite in the hypotenuse? Yes, but there's a preference for using the given sides over and over again.
Okay.
And so we would say cosine of 70 degrees equals adjacent, which is B, over hypotenuse, which is 13.
Hmm.
Is that clear how we did
Yeah.
that? Okay.
Yeah.
Now what I kind of heard is maybe in class, like your teacher's trying to emphasize, like you can also use angle 20, and now
Hmm.
B is opposite from 20. Is that possible? Something you were hearing in class?
Yeah.
Yeah, there's a lot of options. Um, and that's probably why it's confusing. So we'll address that, but for now, let's go ahead and calculate B. B is equal to 13 times the cosine of 70. And let me know. See, I get this is what I get for that 4.4463.
Yeah. Did you round?
Yes.
Okay. Okay.
And I didn't see any rounding instructions on here, so go with whatever they recommend.
Okay. Sorry, I'm a little sick.
No problem. Sorry you're feeling that way. I won't have you talk as much. That's probably not helping.
It was. Okay.
Awesome. All right. I mean, you're welcome. Like if we can do this problem, you're also welcome to say like, to look through them and see which ones make the most sense. But
There was one problem. I don't think it's on. It might not be on this. Let's see. This one, I don't understand how to.
okay, yeah, let's look at this one because this is not a difficult question. You want lots of these on your test,
Mhm.
and I'll show you why here in a moment. All right. There it is. Okay. So before I get to this question, I want to go back up and show you something we actually did earlier. Do you see this thing just to the right, top right of the zero, the
Yeah,
degree
the
symbol?
degree. Yeah.
Do you see that here in this question? Is the degree symbol showing?
No.
So this means degrees. So if it's not there, it does not mean degrees. Like even if your instructor wrote sine 30, if they don't put the sign with the degree symbol, these are not the same.
Okay.
Now it's possible they would make a mistake on a paper test, but they're supposed to look for that. But you're supposed to say to yourself, oh, mode is radian.
Oh, okay.
Okay. So literally all you're doing is typing in, once it's in the right mode, sine 0.75, and here's the number. I'll round it to 4 decimal places, 0.6816. And I'd like you to calculate that too on your own. This is a very important thing that you're able to move back and forth between them.
Okay. I gotta figure out how to change it.
You said it's a Casio FX something?
Yeah.
Do you have any other numbers after that?
300 ES.
Yes, got it. Okay, mode radian. That's a video.
Oh,
Okay.
I see. I think I did it.
Yeah, let Google be your friend also on this one. Yeah, I found a link to that, which I'll throw in the chat as well. And so the you know, the other two are the same. You're just cosine now of that. So like what some teachers like to do is they like to ask a question where they literally ask you, like, what is the difference between sine of like pi and sine of pi degrees? And they're basically asking you like to understand the difference between degree and radian.
Uh-huh.
And as you know, as a new student, like you probably still aren't like, what is a radian? What, you know, we don't need to get into that right now, unless you just know that you've got to move between them
Yeah.
for now.
All right. All right. Yeah. Okay. I'm glad I got that figured out because I was like, why am I not getting this answer right?
Yes, and if you've got other questions like that, you know, please throw them at me, because you know, we don't have to just do problems. We can just go through stuff.
Another thing I don't really understand is reference angles.
Yes, so there was a problem in that previous assignment, but yeah, maybe I can help you navigate to one here, probably be a little further. Keep going. Right there. I mean, we just did that one, but
Yeah.
let's go to another, that one. Let's do
Next
one more.
one?
Yes.
Okay.
Okay, and let me snip it in, but let me give you like just a short kind of the teaching on it. Yeah, let me do that. So I'll come back to that. All right, so let me share my screen. Okay, so let's say you're in quad 1, okay, and let's just say you're at 60 degrees, like you're at a 60-degree angle here. Okay, the reference angle is the angle that's made with the x-axis. So in the first quadrant, it would be 60 degrees. It's whatever that angle is with the x-axis. Now let's look at quadrant 2. This is where it gets more interesting and more of what you're going to care about. So in quadrant 2, okay, and let's say I give you an angle of 100 degrees. Okay, I want the angle with the x-axis. Okay, now there's actually two angles with the x-axis. There's the 100 degrees, and then there's the one, if you keep going, which is 80. So it's a little bit more than that. It's the smaller angle with the x-axis. So here the reference angle is 80 degrees.
Okay.
So it's the angle that's with the x-axis. That's what you want to keep remembering. Okay, now let's go into quadrant 3. So I'm going 90, 180, and let me go another, so this is 210 degrees. Okay, 210 degrees. 90 gets you here, 180 gets you there, but we want the angle with the x-axis. You're actually going back. Okay, so the reference angle is 30 degrees. Now, how did I calculate that? Well, in this case, I did 210 minus 180. But that doesn't always work. Like if you go back to the previous problem, we actually did 180 minus 100.
Uh-huh.
There are formulas for every quadrant, but I don't think they're worth learning unless you've got a really, really strong memory and like to remember stuff.
Mhm.
What I prefer to learn is like, well, what's happening here? I need to go back to that angle to that. So let me give you another third quadrant angle. Let's say you're at 225 degrees. What is the reference angle? And I'm asking you now.
Would I do 270 minus 225?
So that will give you, so what you just told me, which it sounds reasonable. It actually gives you this angle right here, the one in red, but I actually want the blue. See how we kind of went too far? Like you overshot your destination and you got to go back.
Yeah.
Okay, so it's like your friends driving by us and then they went 3 houses down the street. You don't tell them to keep going. You say go back 3 houses, and that's what I'm trying to get you here. So it's actually 225 minus the 180. So it ends up being 45 degrees.
Okay.
Okay, now in quadrant 4, I don't expect you to fully understand this after just a couple examples, but
Mhm.
maybe you at least will say, okay, I get like it's the angle made with the x-axis. So if you go, let's say I give you an angle like this, like 300 degrees. This is 300 degrees. Okay. This is like when you aren't quite there in your trip because you need to keep going. So if you go all the way around a circle, how many degrees is that?
360.
360. And it's like you're that long road trip. Okay, we've gone 300 miles. We still have how many to go, or in this case, how many degrees to go? Because we want to get to 360.
Mm-hmm.
So what's missing? Like we've gone 300, we want to get to 360.
60 degrees.
60 degrees, yeah. Okay, maybe the formulas will help. Let's try it here. Because there's other issues like if you go backwards as well. So if you're in quadrant 1, the reference angle equals the angle.
Mm-hmm.
Okay. In quadrant 2, it is the reference angle is 180 minus, sorry, a little glitch there. Let's let that 180. I got it right there. 180 minus the angle. In quadrant 3, the reference angle is the angle minus 180. In quadrant 4, the reference angle is 360 minus the angle.
Okay.
Sorry, I don't know why it's timing out like that. Okay, so see how there's 4 different like references,
Yeah.
and that's my concern, is that's like a lot to remember, but maybe that will help you in the short term.
Mm-hmm.
Okay. The other thing is that this is in degrees. So if you wanted it in radian, the changes are here. It's pi over 2 minus the angle minus pi. I'm sorry, this is pi, not pi over 2. Pi 180 minus pi. And then the last one is 2 pi minus the angle. And all of this is if you're going counterclockwise.
So
If you're going the other direction, a little bit different. Go ahead.
I had one problem that was like, it was like negative 1,500, something like that.
Yeah.
So how would I think I'm okay with like smaller numbers, but like, negative numbers is what I need help with. I think that was
Yes.
something I was struggling with in
Yes.
class.
Okay. Yeah. So let's do a quick exercise here on that. And I do want to get to your question. So let's say we're going backwards. Okay. So if I go one revolution backwards, how many degrees is that?
Negative
Negative
360.
negative 360. And let's say I go again, another revolution. Now I'm up to negative 720.
Mhm.
And let's say I keep going. Now I'm at negative 180. Okay, so let's say your problem, the one that you cared about, was negative 1140 degrees.
Mhm.
Okay, so let's keep that in mind as I draw the next one here. So what you do is you're supposed to already know that that's 3 revolutions. So you're supposed to say, okay, 1, 2, 3. Okay, now how much more than 1080 is this angle? 60. So this is 0 and this is now like 90 because you're going backwards. So it's like right there. Like it's 2/3 of the way through. Do you see that?
Yeah.
So what is now in terms of the reference angle? Well, you got to go back to the x-axis. So that's 60 degrees. But so in full disclosure, though, sometimes I think these problems are actually meant, they will ask you for one positive coterminal. Maybe that's what they're asking, and one negative coterminal. Do you remember that?
No, not really. I remember the
Okay.
word coterminal, but yeah.
But that's so okay. So to just to tie it all in, I mean, like if you're going backwards, that's what the negative means, and each revolution is 360,
Mhm.
and then you keep going a little bit more to get to the next one. So let's do another example here. I like that. Okay, so let's see here, let's make it a little bit easier. Okay, let's say it's minus 480 degrees.
Okay.
Okay, so you're starting here along the x-axis, but you're going counterclockwise, 360 or minus 360. If I go to this vertical, that's another 90. Okay, so we're up to minus 450, but we got to keep going. We need to go 30 more degrees. So that's about right there.
Okay.
So one revolution, 360, 90, and then a little more. It's like breaking it up into parts that This time the reference angle that was made with the x-axis. So we've gone 450, but we need to get to this one up here. And that's where it can be maybe frustrating, because like you might even want to write out, it's just an idea, like minus 360 here,
Mhm.
minus 450 here, and minus 540 here. And that way you're like, oh, I'm at minus 480, so I need to go another 60 to get there.
Okay.
But reference angles are always positive. Always, always, always.
So like, does the negative have any formulas like the positives do, or is it?
Yes, but they're very much more confusing,
Okay.
which we can do, but it's, yeah, if you would like them, we can. But you also have to have this issue of, like, I'm sorry, let me go back here. These formulas only work if the angle is between 0 and 360. If it's like
Okay.
720 or 750, you have to first make it a reference angle, and then you can get it.
Okay. That's good to know.
All right, I think we should do a few more problems here. If you're okay with that, let me actually, I had one ready to go. So let's look at that. I think it was even in radian, so that'll add some more kind of chaos things to it. So let me actually, I'm going to snip in the page 3 of the unit circle, just to show you like how useful this thing is. So we want 7 pi over 4.
Okay.
So where is that? Where is 7 pi over 4? Which quadrant are we in for 7 pi over 4?
This one, quadrant 4.
7 pi over 4 is right there in quadrant 4. Perfect. Okay. So, but in terms of how you got there, you went this way, counterclockwise, boom. Okay. So now we want the angle with the x-axis. So this is where, because it's in radian, it's like, what is it? So I wrote this down. It's 2 pi minus the angle. You're given 7 pi over 4.
Mhm.
Okay. Now, if you haven't done this fractions in a while, you have to make the same denominator. So it's 8 pi over 4 minus 7 pi over 4, which is 1 pi over 4 pi over 4. And you might be like, oh yeah, that makes sense because there's pi over 4 up there. I'm at the same spot. Yeah, it's pi over 4.
Mhm.
Is that okay? Is that something you feel like you could do on your own?
So the reference angle is pi over 4.
Yes. Yes.
Okay.
Yes. We're
Oh.
kind of doing a lot of topics. So normally I would love to like pick like, we're just going to work on coterminal angles and we'd spend 10 or 15 minutes on that, or we're just going to work on reference angles. There's a lot here. Get comfortable. Okay, so the reference angle is pi over 4, and this is in quadrant 4. Okay, and we said that's important because that helps you to calculate the sine and the cosine. So it's either plus or minus the sine of pi over 4. Now, I wrote this down earlier, ASTC.
Mhm.
So in the fourth quadrant, C stands for cosine. That means cosine is positive. Sine is negative. It's kind of like a light switch. It's either on or off. Cosine is positive in the fourth quadrant. Sine is negative. So we know that this is minus sine pi over 4. Okay. And if you look in the first quadrant up here, pi over 4 is right there in the middle. Sine is the y value, right? X is cosine, y is sine. So that's minus square root of 2 over 2. That's your answer there for that one.
Okay. And cosine you would
Really similar. It's same reference angle, of course. But in the fourth quadrant, cosine is positive because it's the C. C means it's positive.
mhm.
So it's positive cosine pi over 4. You go to the first quadrant of the unit circle, which you're gonna memorize really quickly because you're gonna see the same things over and over again. And it's the x value there, so it's root 2 over 2.
Okay.
And it happens to be the same as the other values. So
Now that I have the circle, it seems a little bit easier because before I didn't say anything about a circle.
yes, and having the right things in front of you really going to help you. You want to, if you can, print it out, have it next to you while you're doing assignments.
I think she said she's gonna give us a paper
Cool.
formula sheet.
Okay, let's do this one if you're okay with it because it's related to the one we just did. Is that okay? And
Yeah.
it's got a negative, which is really cool for us for learning. All right, new share screen. Yes. Okay. All right, so they give you the angle minus 7 pi over 6. Okay, and this is where having a unit circle actually doesn't help you because there is no minus 7 pi over 6. There's positive, but where is negative? So here's what we know when we're going negative. We know we're going the other direction, going clockwise. Okay. So normally what a student wants to do is they want to do minus 90 degrees. And yes, that's true. But in radian, it's minus pi over 2. And if you keep going, it's minus 180 degrees or minus pi. Okay. But you have a denominator of 6. Okay. So that means minus pi over 2 is really minus 3 pi over 6. Is it clear why I wrote that? Because it reduces to a half.
Can you go over it one more time? Someone called me and I missed a little bit of it.
Sorry about that. So the 6 here tells you the denominator that you need, because you're trying to figure out like where is this number? Where is it on the unit circle? And you don't know. So, but you do know that it's minus 90, minus 180, but in radian, it's minus pi over 2 and minus pi. Which still isn't helpful because we need something with a 6 pi over 6. So over here on the left, if I write this as minus 6 pi over 6, do you see that that reduces to minus pi?
Yeah.
And minus pi over 2 is halfway between there. Half of 6 is 3 minus 3 pi over 6. Okay. Now if we keep going, okay, this is minus 270, or it's usually minus 3 pi over 2. But if we use that denominator 6 and you multiply the top and bottom by 3, it's minus 9 pi over 6. And now we can actually tell you where this minus 7 pi over 6 is, because it's past 6 pi over 6, but it's not quite to minus 9 pi over 6. So like it's just a little bit more than 180. Now what some students do is they convert this to degrees and they figure out what that is.
Yeah.
I mean, you can do that. You will like want to eventually like do it in radian, but you know, fine. It's fine if you don't do that. Now there's a kind of a, you know, another trick, which I don't really like, but I know they're pretty popular TikTok videos. So 7 pi over 6 is here. So when it's negative, it just comes, you just flip over the x-axis for that. Like you go to wherever it would be normally, and then you know you flip it.
Flip it. Okay.
Yeah. And yeah, it doesn't matter to me what you use. You got to decide what you're going to want to remember for this. So why did we do all that? Because we wanted the reference angle. Okay, and the reference angle is now pi over 6, because that's the angle made with the x-axis. So even though it's negative, the reference angle is always positive. Okay, but is it positive or negative? ASTC, all students take calculus. So sine in the second quadrant is positive. So this is positive sine pi over 6. Then you go here, sine is the y value. So that's 1/2. There are some other shortcuts. So I apologize if this is not clear, but you know, if you want those, we can go through those as well. But let's keep going here. So cosine pi over 6 plus or minus. In the second quadrant, cosine is negative. So it's really negative cosine pi over 6. Pi over 6 in the first quadrant is this first coordinate pair. Cosine is the x value. So it's minus square root of 3 over 2.
Okay. All right. Oops, that's the wrong thing. What's that?
Would you like us to do something like this?
Trying to think what might be on our test that's coming up soon. Oh, can we do this one?
Sure.
Yeah.
All right, snipping it in, sharing screen. All right. So let's look at A. A says that sine of t is less than 0 or negative. Cosine of t is also less than 0, which is negative. So to do these problems, you draw yourself a quadrant.
Mhm.
ASTC. So where is sine negative? Well, they're all positive in the first quadrant.
Mhm.
Sine is positive in the second. So it must be negative in these two quadrants. And I give them a check mark.
Mhm.
Now we do the same thing for cosine. Where is cosine negative? Well, they're all positive in the first quadrant.
Mhm.
Sine is positive in the second. So that means cosine is negative there. Cosine is also negative in the third because T stands for tangent. I guess I didn't mention that tangent is positive, so the others are negative.
Mhm.
So wherever there's an overlap, that tells you the quadrant that you're in.
Okay. So it's quadrant 3.
Yes, and there will only ever be one quadrant where it works. So you don't have to worry about like, will there ever be, no, that you always get one that works. So
Okay.
B is, let me look at here. So B is sine positive, cosine negative. So again, we'll just draw this ASTC. Okay, where is sine positive? Well, they're all positive in the first quadrant.
Mhm.
And then you look for the one that has S. S is positive in the second quadrant. Okay. Cosine negative. So they're all positive in the first. Sine is positive in the second, which means that cosine is negative.
Yeah.
Okay. And then tangent is positive in the third. That means sine and cosine are negative. So also down there, we've already got our overlap. So it's quadrant 2. Part C, sine is positive, cosine is positive. So this one we like, ASTC. Where is sine positive? The first and the second because of the A and the S. Whereas
Mhm.
cosine positive? The first and the fourth because of the letters. And there you go. There you have it. It's in quadrant 1 because that's where the overlap is.
Okay.
It all comes down to this ASTC.
Yeah.
It's a pretty standard acronym thing. You probably find a or a TikTok, someone making a song out of it. I don't know. All right, last one here on this problem, ASTC. Okay, and so where is sine negative? Well, we know it's positive in the first and the second because of the A and the S, therefore it must be negative down in these other ones. The letter tells you which one is positive.
Mhm.
Where is C cosine positive? Well, where they're all positive, okay, and where cosine is positive. So there's your overlap for
Okay.
those, quadrant 4.
That makes sense.
All right, so this does take us to the end of our lesson. It is 50 minutes.
Mhm.
And so let me just stop sharing here, stop recording for a moment.